Now, there are a couple of other rules that will really help us. One of them is called the constant multiple rule. In words, here's what it says. If we have the derivative with respect to x of a constant times a function f of x, well, it's really the same thing as the constant times the derivative of the function. So that constant times f prime of x. What we're saying right here is that whatever our constant is, the derivative of a constant times a function is the constant times the derivative. So for instance, if I had an expression like this one, the derivative with respect to x of 3x to the fourth, well, what I'm going to do is I'm going to treat this as 3 times whatever I would get from my derivative with respect to x of x to the fourth power. So if I work that out, that becomes 3 times, in this derivative, the derivative of x to the fourth power, the power rule we said was 4 times x to the third power. And so we would multiply our constants together and simplify this as 12x to the third. The last rule that we need to know in this particular list of objectives is the derivative of a sum or difference. And the rule is actually, again, very simple. It says that if you take the derivative of a sum or difference of two functions, the result will be the sum or difference of the derivatives of both of those functions. And we can extend this out to the addition and subtraction of several terms. Here's an example. I'm going to use my derivative to take my derivative rules to take the derivative of 2x cubed minus 3x squared plus 7x minus 1. So the way I could do this, if I really want to detail out all of these rules, is to use my sum and difference rule to begin with. And my sum and difference rule tells me that this is really the same thing as taking the derivative with respect to x of the quantity 2x cubed minus the derivative with respect to x of our next term 3x squared plus the derivative with respect to x of our term 7x and minus the derivative with respect to x of our constant 1. So we know what happens with each of these things, right? By the constant multiple rule, this is the same thing as taking 2 times my derivative of x cubed with respect to x minus 3 times my derivative with respect to x of x squared, pardon me, in this time, plus 7 times the derivative with respect to x of x minus the derivative of this constant is just equal to 0. That term's just going to drop off. And now we're going to have 2 times our derivative of x cubed. We said that's 3 times x to the 3 minus 1, 2 power, minus 3 times 2 times x to the first power, that's just 2x, plus 7 times 1. And so in detail right here, our derivative becomes 6x squared minus 6x plus 7. Well, not too bad. That is our derivative using all of these rules. And we see that when we combine them, it actually becomes a very simple process. And that power rule is a real time saver too.